Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Now we are introducing new topic, that is the thermodynamic and statistical physics. How the CSIR exam pattern and GATE exam pattern and old questions also we have to discuss in this class, right? So please subscribe my channel, that is Quantum Online Academy YouTube channel. If you are interested in my teaching, if you are really aspirant to write the CSIR exam and GATE exam, to write any competitive exam in physics concerning MSc level subject, you have to go to the Play Store and download my app, that is Quantum Online Academy app. From that app, you have to purchase my course. This is a CSIR and GATE physical science course. You have to purchase from the app and you listen the classes. Clear? Right. So now we have to discuss in this class CSIR and GATE, thermodynamics and statistical physics, syllabus, paper pattern, solution of some old questions by Dr. Nagaraju Pendam. That is me, right? So what is the syllabus? Already I told CSIR two type of syllabus are there. One is core A, that is part A syllabus, that is the core syllabus. Next one is the part B syllabus, that is the advanced part syllabus. Recently we uploaded mathematical methods of physics also. Maybe tomorrow and day after tomorrow we have to upload classical mechanics. All 9 chapters, all 9 subjects we have to upload in YouTube. Some important topics also I will explain and upload in YouTube also. Maybe you will get the benefit in your future, right? Now you have to see in part A, what is the core syllabus? Thermodynamics and statistical physics. Thermodynamics and statistical physics, part A. First one is laws of thermodynamics and their consequences. Suppose you have to see zeroth law. What is the physical significance of zeroth law? They will ask like that. What is the physical significance of zeroth law? It indicates the temperature. What is the physical significance of the second law, first law, third law? Like that, they will ask statistical. First part is laws of thermodynamics and their consequences. Next, thermodynamic potentials. 4 potentials are there: internal energy, Helmholtz free energy, enthalpy, Gibbs free energy. These 4 energy functions are there, those thermodynamic potentials. Next, Maxwell relations. These relations different from electromagnetic theory Maxwell equation. In electromagnetic theory Maxwell equation, there are the sources and fields, that a relation between the sources and fields. Here, the Maxwell equation, thermodynamical Maxwell equation, this energy functions will give the thermodynamical Maxwell relations. Next, chemical potential. That chemical potential symbol is mu. Mu is a chemical potential. Phase equilibrium. In phase equilibrium, phase space is there, right? First order phase transition, second order phase transition, how the number of constants, how many constants are there, what is the degree of freedom, everything we have to discuss here, phase space. Next, micro and macro states. Micro and macro state. What is the micro? Micro means we are unable to see with our naked eye. What is the macro? Macro means that is a bigger one. Suppose we are able to see the pen, we are able to see the finger, we are able to see the hand, whatever it may be, those things are macro things. Both things we have to discuss here. Micro-canonical ensemble, canonical ensemble and grand-canonical ensemble. 3 types of varieties of ensembles are there. And their partition functions, free energy and its connection with the thermodynamical quantities. This was also classical and quantum statistics. What is the classical statistics? Classical statistics, who explain the classical statistics? Maxwell, Boltzmann explain the classical statistics. Quantum statistics are the 2 distributions are there. One is the Bose-Einstein statistics, another one is Fermi-Dirac statistics. Ideal Bose gas, Fermi gases, principle of detailed balance, Blackbody radiation and Planck's distribution law. This is the core syllabus of CSIR part A, right? This syllabus is very, very important. After some time I will come to again this side. Now advanced syllabus once you have to see. There we learn the phase transition, phase space, here first order phase transition and second order phase transition. This is very, very important. How the phase is changing. Suppose liquid phase to vapor phase to solid phase to liquid phase to gaseous phase. Like that phase should be transformed from one phase to another phase. How it will be transformed. Suppose I will give one example. Bose-Einstein condensation, which order phase transition they will ask. So based on the Gibbs free energy theory, we have to distribute the phase transition. So those things we will discuss in the classes. Now you listen. Next, diamagnetism, paramagnetism, ferromagnetism, Ising model. This is under magnetism, diamagnetism. Once you have to take the diamagnetic material, you apply the magnetic field, so that material won't accept to flow the magnetic lines within that material. Such type of material, diamagnetic material, based on the susceptibility, we have to distinguish these material permeability, susceptibility, all things we have to learn. Curie temperature, all those things we have to discuss here. Ising model is very, very important. Compulsory one question will come. Pakka in your competitive exam, CSIR exam, Ising model. Next, Bose-Einstein condensation. This is very, very important. Bose-Einstein condensation. Diffusion equations, Fick's laws. So, first Fick's law, second Fick's law, the diffusion equations are there. And random walk and Brownian motion. This is the Einstein theory. Brownian motion. Introduction to non-equilibrium processes. This is the advanced part. Which part it is? Advanced part. Now the research is going on. If anybody interested to do the research, this part is very, very important. Phase transition. This is also burning area. Magnetic materials also burning area to record. So now I am recording. Because of the magnetic material, the magnet is attracting, the receiver is attracting because of the magnet only, right? So that magnetic material is very, very important. To store the data, to record the data, magnetic materials are very, very important. This is also burning area. Ising model also very, very important. Bose-Einstein condensation. This is very, very burning area if you are able to do the research. Diffusion equation, random walk and Brownian motion, non-equilibrium process. Once upon a days, we are thinking those things are equilibrium processes. Now, all equilibrium processes are not existing. Non-equilibrium processes, so only existing. So, this area is very, very important. This is the syllabus of CSIR part A and part B. How the question pattern in CSIR examination? Already I told in mathematical methods of physics, in classical mechanics, quantum mechanics also I told about this. But even though each and every slide I am explaining how the CSIR exam pattern may be. First, total number of questions, 75 questions are there. You have to attempt only 55 questions. You may get 200 marks. You may get 200 marks for 55 questions only. You have to attempt only 20 questions. You get the 100 marks also. That is the possibility is there in CSIR examination. All questions we may not know. 75 out of 75 we may not know. Only little bit we know. At least 50% you come to know the answers. Then you qualify the CSIR examination. Not only qualify, you get the JRF also. Maximum number of questions to attempt in part A. Part A belongs to whom? Part A belongs to the general aptitude. This general aptitude with emphasis on logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation, puzzles. So these questions you get in general aptitude. General aptitude, how many questions you will get in CSIR examination? You will get 20 questions. How many questions you have to attempt? You have to attempt only 15. Out of 20, only 15 you have to do. Any 15 you have to do. Each question carry 2 marks. Each question for wrong answer, you may lose 0.5 marks. This is a general aptitude part. This part we are not giving the coaching. only we are giving the coaching for part B and part C. Part B you have to see 25 questions are there. Each and every question carries the 3.5 marks. This is belongs to which subject? This is belongs to physics only. Majority of the subject core, from core only we are getting this one. 20 questions you have to attempt. Each and every question 3.5 marks. Each and every wrong question you may lose 0.875 marks. Clear? Now part C. You are coming into the part C. Each and every question shall carry 5 marks. Right? So this one also physics. Most of the parts will come core plus advanced part. Advanced part and core part also syllabus will come. 30 total number of questions are 30. You have to attempt only 20 questions. Each and every question shall carry 5 marks. You may lose for wrong question 1.2 marks. Be carefully you have to do. For negative, whatever the question you know pakka, that question only you have to attempt. Then only you able to get the success in competitive examination. This is the exam pattern. Clear? What is the exam pattern? In CSIR, we have two parts of the syllabus. One is core A, another one is core B. From core A, questions will come. From core B also questions will come. Core A, majority part, 3.5 marks question they may ask. From core B, 5 marks question, pakka it will come. From core A also 5 marks questions they will ask. That based on the strength of the examination. Part A belongs to general aptitude only. This is the CSIR syllabus and exam pattern. Now we will see the GATE, Graduate Aptitude Test in Engineering. Actually, one technical degree is equivalent to for post-graduation. After completion of the post-graduation, people want to enter into the MTech degree or PhD in IITs, IITs and NITs, ISIR or any laboratory, PSU sector laboratory also. If you want to enter, GATE also one gateway, right? It is a window to enter in that. So GATE also very, very important examination. Please concentrate on this examination also. What is the syllabus in GATE section 5? Section 5 matlab Thermodynamics and Statistical Physics. Which one it is? Thermodynamics and Statistical Physics. In Thermodynamics and Statistical Physics, laws of thermodynamics there also is there. Macro states and micro states there also is there. Phase space there also is there. Ensembles, partition functions, free energy calculation of thermodynamic quantities, classical and quantum statistics, degenerate Fermi gases, Blackbody radiation, Planck's distribution law, Bose-Einstein condensation, first order and second order phase transitions, phase equilibrium, critical point. All the syllabus, whatever the syllabus is there in the CSIR, most of the syllabus is covered in GATE. Some little bit topic. What little bit topic? Ising model, paramagnetism, diamagnetism, ferromagnetism, except magnetic material. Except magnetic material, rest of the syllabus is the same for GATE examination. Clear? Now we will see the pattern of the GATE. GATE only 100 marks. GATE exam for 100 marks only. If it is CSIR exam 200 marks, GATE is 100 marks. Within 100 marks, 15 marks only general aptitude. General aptitude only for 15 marks. 1 to 5 questions shall carry 1 mark. 6 to 10 questions can carry 2 marks. Out of these 5 plus 2, 5 are 10, 15. 15 questions you have to attempt. Each and every question you have to attempt. Part A, general aptitude. In part B, that is the physics, how many marks, Nana? 85 marks. From physics, you will get the 85 marks. 11 to 35, question number 11 to 35, you will get the 1 mark for each and every question. From 36 to 65, each and every question, you will get 2 marks questions. 2 marks question. Some strength is more. You have to calculate and you have to exercise that one. Here in physics, multiple choice questions are there. These are MCQ, first variety. And multiple selected questions are there. This is the second variety. And next, numerical answer type questions are there. This is the third variety. Total 3 varieties are there. Numerical answer type question. You have to enter the answer with your virtual keyboard. This is purely computer based examination. Clear? GATE exam pattern, it is also 2 types. One is general aptitude, that is a 15 marks only. Here physics 85 marks. Multiple choice questions are there. Multiple select questions are there. Numerical answer type questions are there. In multiple choice questions means among the 4 options, 1 option is correct. In multiple select questions means among the 4 options, more than 1 or 2, more than 2 options correct. So such options you have to select, right? Numerical answer type question, that is the problem, that value you have to enter in the whatever the box is there, in that box you have to enter that value. This is the exam pattern. Clear? Now, what are the reference books? We know the syllabus now. Thermodynamics and Statistical Physics syllabus, you know. Now, what books we have to refer to follow these syllabus? First, you have to see Statistical Mechanics Patharia, R.K. Patharia. This book is very, very important, easy also. Fundamentals of Statistical and Thermal Physics, Reef. It is very, very essential book for statistical mechanics. This book is very nice. Statistical Mechanics, Donald A. McQuarrie. This also nice. Introduction to Statistical Physics, Kerson and Hagen. And topics in Statistical Mechanics, Brain Cowan. Statistical Mechanics, J. Hoods Halley. An Introduction to Thermodynamics and Statistical Mechanics, Keith Stowe. These books are very, very popular books. This one is a Stanford University book. This one is the Cambridge University Press book. These books you won't get in your library or whatever it may be in your market. This book is available in the market. Reef also available in the market. You have to follow any one book also enough, right? These are the reference books for a statistical mechanics and thermodynamics. Now, we will inform you small request. CSIR and GATE batch we want to start from 7th January 2024 onwards. This is a live plus recorded classes, not in YouTube. This is completely app. You have to go to the Android mobile phone. If you have Android mobile phone, not Apple, Android mobile phone. In Play Store, you enter the Quantum Online Academy app. You have to download. From that app, you have to purchase the course. Which course? CSIR and GATE batch course. In that course, you have to listen CSIR, GATE, physical science classes. Clear? Now, this recorded classes every day, live classes every day 6 AM to 8 AM. Every day except Sunday. Sunday we have to conduct the exam. So that's why we are unable to take the class. 6 AM to 8 AM, that is the live class is available. If you are not present in the live, that recorded class will be available in a app. That any free time you have to listen. This course validity is 1 year validity is there. This course duration also 1 year, because to complete the course we have to take a duration also 1 year. Course duration also 1 year. Within the 1 year, we have to finish the entire syllabus. Please concentrate and you have to purchase. Now, we have to segregate. Suppose now you will see the syllabus, you are afraid because syllabus is vast is there. To complete the syllabus, book also very bigger book. Notation also, difficult notations are there. Because thermodynamics and statistical mechanics also equal to the quantum concepts only. We are unable to see we are unable to think, complete abstract thinking is there in quantum statistics. So that's why which type of way follow to read the syllabus. That's why we segregated into 10 parts. Each and every subject I am segregating 10 number of parts. That's why I am segregating once you have to see. Like this you have to segregate and you read, you will get the more perfection in your subject. First you see laws of thermodynamics and thermodynamical potential. How many laws are there? 3 laws are there. Zeroth law, first law, second law and third law also now existing. Thermodynamical potential. How many potentials are there? 4 potentials are there. So those potentials you have to read. What potentials are there? Enthalpy, Helmholtz free energy, Gibbs function, internal energy. These 4 potentials are there. Among these 4 potential, 4 thermodynamical Maxwell relations and chemical potential also included only. In CSIR, you may get 32.5 marks from this paper. In GATE, you have to get only 16 marks you will get in GATE. GATE, you will get only 16 marks. You will get the first law of thermodynamics and thermodynamic potential, 3.5 marks. In GATE, 1 mark you have to get. In Maxwell relations and chemical potential, this question come 5 marks question. 2 marks from GATE you are getting. Phase space, microstate and macro states you get in 3.5 marks and 2 marks in GATE. Ensembles, 3 types of ensembles are there. One is canonical ensemble, grand-canonical ensemble, micro-canonical ensemble. And their partition functions also. You will get the 10 marks, 2 marks in GATE. Free energy and its connection with thermodynamical quantities, 10 marks in CSIR, 1 mark in GATE. Classical statistics, you may get 3.5 marks in CSIR, 2 marks in GATE. Quantum statistics, you may get 10 marks in CSIR, 1 mark in GATE. Blackbody radiation, you may get 5 marks in CSIR and 2 marks question you may get in GATE examination. Magnetism, here magnetism is there, diamagnetism, paramagnetism, ferromagnetism and Ising model. 5 marks in CSIR and 0 marks in GATE examination. In GATE examination, you won't get any one. You won't get any. Why you won't get any? Because this syllabus is only for CSIR. This syllabus is only for CSIR, not GATE. Right? Random walk, Brownian motion, non-equilibrium processes also only for CSIR. This syllabus also only for CSIR, not for GATE. 5 marks in CSIR and 0 marks in GATE examination. Clear? This is the syllabus. I segregated into 10 parts. From each and every part, I took one question from previous year questions. Previous year questions, whatever the previously asked questions are there now in CSIR examination or GATE examination. From that, I segregated 10 questions I am giving in this video, right? You able to get the idea what are the questions, how we have to solve. One question we will see. First one you have to see. From first part I am able to do. A thermodynamic function that is the Gibbs function. Thermodynamic function they are giving. Which function it is, Nana? That function is itself a Gibbs function. A thermodynamic function, that function is the Gibbs function. G is equal to U minus Ts plus P into V. P into V, PV. U minus Ts plus PV. This is the Gibbs function. Right? They gave. Is given in terms of the internal energy U, temperature T, entropy S, pressure P, volume V, the number of particles N. Which of the following relation is true? In the following, mu is the chemical potential. Already I gave mu is the chemical potential. How we have to identify this option? First you have to solve. First you have to take this expression and differentiate explicitly. Differentiate explicitly matlab dg is equal to du minus t into ds minus s into dt plus p into dv plus v into dp. Explicitly I am differentiating. After that, you know one thing. What you know, Nana? You know one thing. What you know? du is equal to TDS minus PDV. du is equal to TDS minus PDV. How it come? You know the thermodynamic first law. dq is equal to du plus PDV. dw, this is the thermodynamic first law. dq is equal to du plus dw. Now, dq is equal to, according to the thermodynamic second law, TDS is equal to du plus dw is equal to, which one we have to write? PdV. Now we need to write du is equal to TDS minus PdV. du is equal to, which one we have to write? TDS minus PdV. Therefore, you substitute there you have to substitute dg is equal to, instead of du, what should I write? TDS minus PdV minus TDS minus SDT plus PdV plus VDP is there. Now, any cancelling there? Plus TDS minus TDS plus PdV minus PdV get cancelled. Therefore, dg is equal to, rest of the thing you have to write, minus SDT plus PdV plus PdV minus SDT plus PdV is there. Which one we have to write, Nana? Minus SDT plus PdV. This is the entropy, Gibbs function. dg is equal to minus SDT plus PdV. From this, we have to analyze the option. How we have to analyze the option? One more thing we have to see. How we have to analyze the option. What we got? dg is equal to minus SDT plus PdV we got. Correct? First you have to differentiate plus you take mu dn. If it is n is a number of particles. If you have to consider n is a number of particles, because in the problem they are giving n is the number of particles. What is the mu? Mu is a chemical potential. Mu is the chemical potential. Clear? Mu is a chemical potential. Now you have to see. If you want to get the S, how we have to calculate? Dou g by, you have to do the partial derivation. Dou g by dou t at a constant v comma n, VDP, no? VDP you got, no? Which one you have to get? VDP you have to get it. Sorry. You have to see here, this is rest of the thing, VDP is there. VDP is there. Once you have to check it. VDP is there. This one is VDP. Minus SDT plus VDP. Now, you have to do this to get the dou g by dou t. Dou g by dou t. For S we need to get. That's why what we have to do? At a constant pressure and number of particles is equal to minus S we are writing. Minus S. Therefore, S is equal to minus dou g by dou t at a constant pressure and number of particles. This is one way. Next, second one, what we have to write? Dou g by, if you want to get the V, dou g by dou p at a constant t comma n is equal to V we have to write. Now you have to see the option. S is equal to minus dou g by dou t p comma n. V is equal to minus dou g by dou p t comma n. From now you got the option. First you have to see. S is equal to minus dou g by dou t n comma p. This option A is correct. Now you have to see. S is equal to dou G by dou T, N comma P is wrong because here minus symbol is there. Minus symbol is not there, that's why wrong. V is equal to, what is V Nana? V is equal to dou G by dou P, N comma T. Minus is not there. Here mu is equal to, mu we are not getting the mu because we are writing for, so G value, we are writing for S value. These values are very, very important. Dou G by dou N and P comma T. Minus dou G by dou N, P comma T also not correct. Clear? Like this we have to solve. Understood? First you have to differentiate explicitly this expression. After differentiating, what you have to write? So next you added the chemical potential mu dN you have to add. From this you have to assume the answer. Which one is the correct option? You will get. What is the correct option? Option A is correct. When they asked this question, June 2017 CSIR, that time they are asking. June 2017, right? This is the first part. From thermodynamical potential they are asking the question. Now you able to see next part. Next part I segregated Maxwell relations and chemical potential and thermodynamical potential. Now you have to see here which of the following sets of the Maxwell relations is correct. Which of the following sets of the Maxwell relations is correct. They are asking first internal energy U is equal to, internal energy U is equal to, what is the U Nana? Du is equal to, now only we got TdS minus PdV. TdS minus PdV. This is a du is equal to internal energy. One thing we have to discuss. Internal energy. Next, enthalpy, what they are giving? Enthalpy dH is equal to, what is the enthalpy? Once you have to see, dH is equal to the TdS plus VdP. TdS plus VdP, enthalpy. Next, you have to see here Gibbs free energy. Now only we got the Gibbs free energy. What is the Gibbs free energy, Nana? Minus SdT plus VdP. Minus SdT plus VdP. This is a Gibbs free energy. Minus SdT plus VdP. That is the Gibbs energy. Next, Helmholtz free energy. dF is equal to, what is the Helmholtz free energy? Helmholtz free energy dF is equal to minus SdT minus PdV. Minus SdT minus PdV. This is the functions. Please remember, internal energy is the function of S and V. Enthalpy is the function of S and P, right? Gibbs free energy in the function of T and P, and Helmholtz free energy is the function of T and V. This is also very, very important. Sometimes these questions also they will ask. Internal energy is the function of which parameter? Helmholtz free energy is the function of which parameter? Gibbs free energy in the function of which parameter? They will ask. First we will see. One thing we will see. First, dou U by dou V at S. Dou U by dou V at S is equal to which one we are getting? Minus P. That's why it is correct. Wrong. Now you have to see. Dou U by dou S. Dou U by dou S at a constant V is equal to which one we are getting? Nana? T. This option also wrong. Option A is wrong. Now we have to see for the option B. What is option B? I am coming to the H. Dou H by dou P. Dou H by dou P at a constant S is equal to what we are getting? T. But this option also correct. Wrong. Now dou H by dou S at a constant P is equal to which one we want to get? V. But here T is there. This is also wrong. This option also wrong. Now we will see the Gibbs. Dou G by dou T. Dou G by dou T at constant pressure is equal to S. Dou G by dou T. Dou G by which one we are writing? Dou G by dou V at a constant dou G by dou T at a constant, this is the G, no? Dou G by dou V at a constant dou G by dou V, dou T. Dou T is not there. Right here, dou G by dou P at a constant S is equal to. This option also correct? Not correct. This option also not correct. Now I am coming into the Helmholtz free energy function. What is the Helmholtz free energy function? Now you have to see dou F by dou T. Dou F by dou T, some mismatch is there. Dou F by dou T, dou F by dou T at a constant V. Dou F by dou T at a constant V is equal to dou F by dou T at a constant V is equal to S. No, this is also wrong. Dou P is equal to, here P is there, dou F by dou T at a constant. This is also wrong. All options are wrong is there. But you have to see one adjustment I will do. Any adjustment I will do, you have to see. First option I make it correct. First option I make it correct once you have to see. How I have to make it correct the first option once you have to see. How I am making the correct one, you have to see the first option. Otherwise the second option, once you have to see the second option, dou H by dou P. Dou H by dou P at a constant entropy is equal to V. Oh, second option is correct. Sorry. Second option is correct. Dou H by dou P at a constant entropy is equal to right. Next, dou H by dou S at a constant pressure is equal to V. Not T. This is V. If it is V, that is the correct, right? Among this option, you have to see this is not T, right? Some printing mistake is there. This is the V. Dou H by dou S, dou H by dou S, dou H by dou S at a constant P is equal to V. Option B is correct. Once you have to check it based on your rules, you have to check it. Once again, I will teach how we have to get. Once you have to see here. First, the internal energy, according to the thermodynamic first law, dq is equal to du plus dw. The heat is, you have to give the heat to any substances. The substances will occupy the energy, right? It will work to develop the internal particle energy and simultaneously it do some external work. But according to the thermodynamic second law, thermodynamic second law, what is the thermodynamic second law? dq is equal to tds. tds is equal to du. dw is equal to, this is a pdv. dw is equal to pdv. Now you know the du is equal to, how we have to write? tds minus pdv. du is equal to tds minus pdv. How we are getting from this, once you have to see. One I will explain, then later you have to know. tds minus pdv. Minus pdv. If you have to differentiate, partial differentiation, dou u by dou s at a constant volume is equal to T. Dou u by dou v at a constant entropy is equal to minus P. Like this you have to do, right? Each and every one. 4 fundamental potentials you have to take. From that potentials, one time you have to take, one is the constant, another one you have to take it as a for purpose of, if you want to calculate the temperature, rest of the thing you have to take it as a constant. If you want to calculate the pressure, so another one you have to take it as a constant. If S is a constant, S is equal to 0. That is the thing. Partial derivation. Partial derivation you have to do. Both sides you have to do the partial derivation. With respect to that term, you able to finish that one. Clear? This is the second one. Like this we will get the questions. That is also 3.5 marks question or 5 marks question. The strength of the question based on that. Now you have to see third one. Third one is the phase space or phase transition, microstates and macrostates the system is there. across a first order phase transition, the free energy is, what is the first order phase transition? Suppose you have to see the first order phase transition. Here, the first order phase transition. This is very, very important. Compulsory questions will get in any competitive exam, not CSIR or GATE. In any competitive exam, without phase transition, question paper won't be there. What it indicates? That Gibbs function is, Gibbs free energy is continuous. The Gibbs free energy is continuous. But the first derivative of the Gibbs free energy, dou G by dou T, the first derivative with respect to temperature or pressure, whatever it may be, is discontinuous. The first derivative for first order phase transition, which one is? G is continuous, but the first derivative is discontinuous. The first derivative of the Gibbs function with respect to temperature and pressure is discontinuous. How it is? Once you have to see the graphs, first you have to take the graph Gibbs function versus temperature. This graph will come like this, right? If you have to take a first derivative, if you have to take dou G by dou T versus temperature, if you have to take, there is a discontinuity in there. Which one is there? There is a discontinuity. Here there is a discontinuity. Here continuous is there. Now you have to see. Proportional to the temperature, wrong. A discontinuous function of the temperature, is wrong because the function of the temperature is continuous. A continuous function of the temperature, but first derivative is discontinuous. C option is correct. Such that the first derivative with respect to the temperature is continuous. D option is wrong. Which option is correct? C is correct. That function is continuous. Once you know the function is continuous, the first derivative with respect to the temperature is discontinuous for first order phase transition. This is very, very important one. So you have to listen this one. Clear? Now we will see the fourth one. So what is the fourth one? It is very, very important one. An atom has a non-degenerate ground state. One atom is there. That atom has a non-degenerate ground state. Suppose you have to take here a non-degenerate ground state is there. This is the non-degenerate ground state. That energy is equal to 0 if you have to take. Next, the same atom has a doubly degenerate excited state. There is excited state is there. This excited state is a doubly degenerated. That energy is equal to, if you have to take this energy is equal to E if you have to take doubly degenerated, right? So this energy, ground state energy is equal to 0. That first excited state energy is equal to E. Why I am taking like that? The energy difference between these two states is equal to, what is the energy difference between these two states? E. That's why I have to take E minus 0 is equal to E. Next, the specific heat at very low temperature, beta E is greater than 1 is given below. What is the specific heat they are asking? This is a bigger question, 5 marks question. 2016 GATE examination time they are asking this one. We need to solve this question. How we have to solve? Once we have to see. Already I explained. Here one particle is there. That ground state energy is equal to E is equal to 0. The first excited state is doubly degenerated. That energy is equal to E. E is equal to E, doubly degenerated. So the energy difference between the E and E energy is equal to E is there. Now we need to calculate the partition function. How we have to calculate the partition function? Once you have to see. The partition function formula Z is equal to summation of S e to the power of minus beta into Es. This is a partition function story. Which one it is, Nana? Partition function z is equal to summation of s e to the power of minus beta into es. First you have to substitute. First how we have to substitute? Z is equal to summation of, how we have to write? First function I am applying e to the power of minus beta into 0 plus e to the power of minus beta into e plus e to the power of minus beta into e. Z is equal to e to the power of 0, any power 0 is equal to 1, any power 0 is equal to 1 plus e to the power of minus beta into e plus e to the power of minus beta into e plus 2 e to the power of beta into e. This is the partition function. First we calculated the partition function. But they are asking the specific heat under the low temperature they are asking. To find the specific heat, we have to calculate the internal energy. How we have to calculate the internal energy? Once you have to see, there is a principle for the internal energy. U is equal to minus dou by dou beta of, which one we have to write, Nana? Ln Z. So this is the principle of internal energy principle. Now you have to substitute. How we have to substitute? Once you have to see, minus dou by dou beta of ln z is equal to, what is the z value? Partition function 1 plus 2 e to the power of minus beta into e. Now you have to differentiate. Dou by dou x of ln z is equal to, what we have to write, Nana? 1 by x. We have to write, here minus is there, 1 by 1 plus 2 into e to the power of minus beta into e. Again you have to differentiate, this one is 0 plus 2 into e to the power of minus beta into e. Again you have to differentiate this value. That value if you have to differentiate with respect to beta, minus e it will come. Clear? Minus beta into e means you have to get the e value. Therefore, minus into minus plus, here 1 minus is there, here 1 minus is there. 2e e to the power of minus beta e is divided by 1 plus 2 into e to the power of minus beta e, which is equal to energy is equal. We got the energy, but what they are asking? They are asking about the specific heat. What is the specific heat formula? Cv is equal to dou u by dou t at a constant volume. But now we find the u value. Now you have to substitute there. Then you have to calculate. What is the u value, Nana? 2e e to the power of minus beta e is divided by 1 plus 2 into e to the power of minus beta e. Now you have to see one more slide we have to take. Now our goal is specific heat we need to calculate. Dou u by dou t at a constant volume is the specific heat. You know the u value, dou by dou t of, which one we have to write? 2e e to the power of minus beta into e is divided by 1 plus 2 into e to the power of minus beta into e, correct? But you know beta is equal to which one it is? 1 by kt. With respect to t differentiation is there, that's why you have to substitute. Therefore is equal to dou by dou t of, you have to substitute here 2e e to the power of minus e by kt, e to the power of minus e by kt is divided by 1 plus 2 into e to the power of minus e by kt is there. But this is the differentiation. What differentiation? D by dx of u by v differentiation. Therefore, d by dx of u by v is equal to v square v u dash minus u v dash you have to take. From this, you calculate the value. How much value you are getting once you have to see. This is the v value. V square. V square means 1 plus 2 into e to the power of minus e by kt whole square we have to do. V into 1 plus 2 into e to the power of minus e by kt into u dash. U is equal to what it is, Nana? 2e into e to the power of minus e by kt into, again you have to differentiate minus e by k into minus 1 by t square. Minus 1 by t square, right? Minus into minus, it will become as a plus. Now minus, next what we have to do? U into 2e e to the power of minus e by kt, v dash is equal to 0 plus 2e e to the power of minus e by kt into minus e by k into minus 1 by t square you are getting. Minus 1 by t square. Therefore, you have to multiply the things. How the things it will come once you have to see here. Now, you will see here 2 into e square. 2e square is divided by kt square. 2e square is divided by kt square. E to the power of minus e by kt. E to the power of minus e by kt plus 4e square into which one we have to write is divided by kt square. 4e square into kt square e to the power of minus 2e by kt. E to the power of minus 2e by kt. Here you have to see 4e square plus 4 minus, it is a minus because here minus into minus plus, this one is a minus is there. Minus 4e square e to the power of is divided by kt square into e to the power of minus 2e by kt. E is divided by, total divided by is there. 1 plus 2e e to the power of is divided by kt is there. Minus plus get cancel, right? Next, what is the remaining thing is there? The whole square is there, no? Right? So, you know what they are giving? Beta e is greater than 1. Beta is greater than 1 means 1 by beta is beta e tends to infinite. Beta e tends to infinite. How it will come beta e tends to infinite? 1 by kt is a lower temperature. Temperature towards 0 means something by 0 is equal to what you are getting? Infinite you are getting, right? So, e to the power of minus infinite is equal to 0. So, 0 plus 1 is equal to 1. 1 square is equal to 1 we are getting. Therefore, ultimately what value you are getting? You are getting the value CV is equal to which one we are getting once you have to see. CV is equal to, you have to take a 2e square. 2e square is divided by kt square into e to the power of, which one it is, Nana? E to the power of minus e by kt. E to the power of minus e by kt means beta into t. Now, I am multiplying with k and divided with k. Any problem? No problem. Now, you have to see CV is equal to 2k into what we have to write once you have to see k square t square. K square t square is equal to 2k e square is divided by k square t square e to the power of beta into e. Therefore, CV is equal to 2k e square. This one what we have to write? Beta square, because beta is equal to 1 by kt. Beta is equal to 1 by kt. Therefore, beta square e to the power of minus beta into e. Therefore, what we have to write, Nana? 2k into e beta whole square e to the power of minus beta into e. This is your correct option. This is the specific heat. Like this we have to solve because it is a 5 marks question. That's why the strength is there. How we have to calculate? What is your option? Option C is correct. Now, once again you have to see an atom has non-degenerate ground state and doubly degenerate excited state. The energy difference between the two states is E. The specific heat at very low temperature is 2k beta E whole square e to the power of minus beta into E. Once you have to check the answer, which one you are getting? 2k E beta whole square e to the power of minus beta into E. Like this questions will get, right? Now we will see the one more type of variety of the question. A system of n non-interacting classical particles. Here what type of particles are there, Nana? A system of n non-interacting classical particles, each of mass m, two-dimensional harmonic potential is there. Suppose you have to see here, this is also very important area of the question, right? Like these questions you will get in your competitive examination. You are unable to do, without coaching, you are unable to do such type of questions. These very complicated type of questions are there. First, how many dimensions are there? A two-dimensional harmonic potential. That is defined as V of r is equal to alpha x square into alpha y square, alpha into x square plus y square, where alpha is a positive constant. The canonical partition function of the system at temperature is T, beta is equal to KT. What they are asking? They are asking about the partition function is equal to how much? The canonical partition function. It is a classical system. To write the partition function, how we have to write a two-dimensional partition function? A two-dimensional partition function is equal to 1 by h square into integral minus infinity to plus infinite e to the power of minus beta into e to the power of minus beta into, which one we have to write, Nana? Es, e to the power of minus beta into Es. So plus, so we have to write here dqi into dpi. This is the relation. Partition function in two dimensions. If it is a three dimensional, it is a classical particle. It is not quantum. Classical particle is there. Which particle it is? Classical particle. If n number of particles are there, what will happen? We have to see. N number of particles also existing, n interacting particle. These particles are n number of classical particle. Whole to the power of n it will come. After some time, I will explain. This is the n number. If it is n number, you have to get a whole to the power of n also. Now we have to calculate. How we have to calculate this one, we will see. Right? Once you have to see the solution, how we have to solve. First, energy we need to calculate. What is the formula? Formula, first one particle we have to take 1 by h square into integral minus infinity to plus infinite e to the power of minus beta into Es into dqi into dpi is there. But they gave the V of r potential energy for a two-dimensional alpha into x square plus y square, which is equal to alpha into x square plus alpha into y square. But kinetic the energy E is equal to, this is the kinetic energy plus potential energy. Both energies are there. What is the kinetic energy? E is equal to kinetic energy in two-dimensional. We have to write px square by 2m plus py square by 2m plus V of r is equal to alpha x square alpha y square, which is equal to energy is equal. We got the energy value. Just we have to substitute this value. There we have to substitute. Once we have to see first Z1 for one particle I am considering. Once you have to see 1 by h square into integral minus infinity to plus infinite. How we have to write? So you have to see instead of Es, we have to write this. Minus beta into px square is divided by 2m into dpi px. Integral minus infinity to plus infinite minus beta into py square is divided by 2m into dpy into integral minus infinity to plus infinite minus which one we have to write? Minus beta into alpha x square exponential of we have to write this one in terms of exponential. In terms of exponential we have to write exponential of into dx integral minus infinite to plus infinite. What we have to write, Nana? Plus infinite, minus infinite to plus infinite, e to the power of minus beta, beta into alpha y square into dy. So such type of partition function we have to write. But you know one thing, what you know? Integral minus infinite to plus infinite, e to the power of minus ax square is equal to root 5 by a. This is the principle. E to the power of minus infinite to plus infinite, e to the power of minus ax square is divided by dx is equal to, which one we have to write? Root 5 by a. Therefore, you have to apply here. Z1 is equal to 1 by h square into 1 by h square into, which one we have to write, Nana? Root 5 is divided by, instead of a, what is there? Beta by 2m. So, beta by 2m is there. Instead of a is equal to, you have to write it as a beta by 2m into square root of 5 is divided by beta by 2m into root, we have to write here 5 is divided by alpha into beta. Here also 5 is divided by alpha into beta. Now you have to simplify. How much you are getting once you have to see. We will see that how much value we are getting after simplifying. Z1 is equal to 1 by h square into 1 by h square root 5 by beta, you know, beta is equal to 1 by kt, correct? Beta is equal to 1 by kt. So, beta by 2m is there. So, that's why which one we have to write? 1 by 2m into kt is divided by 5 is divided by 2m into kt, 1 by 2m into kt into root 5 by alpha into beta into root 5 by alpha into beta. But you know one thing, ZA1 is equal to root 5 by, so then denominator by denominator it goes to the numerator value 1 by h square into, which one we have to write, Nana? 2 phi mkt whole square into 5 by alpha beta, not whole square, 2 phi mkt, root 2 phi mkt, root 2 phi mkt is there, alpha beta is there. Now you will able to see Z1 is equal to 5 into 5, 2 phi square m is divided by 2 phi square m. So beta kt is there, kt is equal to 1 by beta we have to write, is divided by h square beta into beta, beta square alpha. 2 phi square m, is there any one is there? Nothing is there. That's why we have to write here 2 phi square m is divided by h square beta square into alpha. For one particle, if you have to take n non-interacting particle, if you consider interacting particle, how many particles you are considering? N non-interacting particles you are considering. Therefore, Zn is equal to, which one we have to write, Nana? 2 phi square m is divided by h square beta square alpha whole to the power of n you have to write. This is your expected answer. Once you have to check the answers, which answer is there, once you have to check, right? What is the thing once you have to see? 2 phi square m is divided by alpha beta square whole to the power of n. Option D is correct. Like this we have to solve. Clear? Like this we have to solve. This question also very important. So many times they are asking such type of question. June 2015 CSIR people are asking. Like this we have to solve. First we know what is the thing is going on. How we have to identify the partition function. How we have to connect it into the thermodynamical quantities. That is very important. Whether it may be canonical ensemble, grand canonical ensemble, micro canonical ensemble, whatever it may be. Whether it may be photon gas, boson gas or Maxwell Boltzmann gas, anything if you have to take, we have to apply like this only. Now we will see one more, we have to see what is the thing you have to take. The number of ways of a distribution. This is the classical statistics question. What is the classical statistics question? The number of ways distributing 11 indistinguishable particles are there. Suppose you have to take n is equal to 11 number of particles that are boson. 3 different energy levels, that is Gi is equal to 3 different energy levels are there. This is a boson. If it is a boson particle, right? Particle is a boson, then that exists Bose-Einstein distribution. Bose-Einstein distribution law. Bose-Einstein distribution. In Bose-Einstein distribution, what is the number of thermodynamical probability? That is the number of ways of distribution also we have to take. What is the thermodynamical probability? The thermodynamical probability for a Bose-Einstein is equal to Ni plus Gi minus 1 factorial is divided by Ni factorial into Gi minus 1 factorial. Ni factorial into Gi minus 1 factorial. This is a Bose-Einstein distribution law or Bose-Einstein distribution way or thermodynamical probability of Bose-Einstein distribution. Now simply you have to substitute Ni is equal to 11 plus Gi is equal to 3 minus 1 factorial is divided by Ni factorial is equal to 11 factorial Gi minus 1 3 minus 1 factorial is equal to 14 minus 3 is equal to 13 factorial is divided by 2 factorial into 11 factorial. This is a Bose-Einstein number of distribution of the particle. What is the answer? Your option C is the correct option. 13 factorial is divided by 2 factorial into 11 factorial. That is a Bose-Einstein distribution. 13 factorial is divided by 2 factorial into 11 factorial. This is very important question. This one belongs to the classical statistics, number of ways. This boson is a quantum statistical particle only, but in classical and statistics we have to describe in 2 ways. One is the classical statistics, another one is the quantum statistics. There the distribution laws are there. From the distribution law you able to learn, then it is very easy to identify that one. Now we will see what is the thing you have to take. The 7th one. If the number density of a free electron gas, this is very important. Free electron gas is nothing but Fermi gas. Which gas it is, Nana? Fermi gas. Electron is a fermion. That gas of the electron we call it as a Fermi gas. In the Fermi gas, 3 dimensions are there. There is increased 8 times. Which is increased? The number density is increased. What is the number density? The number density is equal to number of molecules is divided by total number of volume. That is the number density. What they are asking? Its a Fermi temperature will be. Its Fermi temperature is equal to, how we have to write the Fermi energy is equal to Boltzmann constant into the Fermi temperature. If you know the Fermi temperature, so Fermi energy, so similarly Fermi energy is proportional to the Fermi temperature. Fermi energy we have to calculate first. What is the Fermi energy? Once you have to see that Fermi energy EF is equal to h square by 2m into 3n by gs 3n gs into 5 all to the power of 3 by 2. This is the formula for a Fermi energy. h square by 2m into 3n 45 gs into 3 by 2. Therefore, we have to write here EF is directly proportional to n to the power of 3 by 2. EF is direct. But our n is how many times increased? 8 times increased. Our n is 8 times increased, matlab what we have to write? EF is directly proportional to 8n whole to the power of 3 by 2. 8n whole to the power of 3 by 2 means EF 8 to the power of 3 by 2 into n to the power of 3 by 2. 8 to the power of 3 by 2 is equal to how much value you have to get? EF is directly proportional to 2 cube whole to the power of 3 by 2. So now we have to take 2 by 3 this one. 3 by 2, 2 to the power of 8. You have to take 8 times increased. How many times you have to? 2 by 3. This one you have to take 2 by 3. This 2 by 3. This formula is 2 by 3. EF is directly proportional to 2 by 3. Not 3 by 2. 2 by 3 is there. So please adjust. 2 by 3. 2 by 3. Right? Once you have to check it. EF is directly proportional to 3 get cancelled. Now you have to get 4 into n to the power of 2 by 3. N to the power of 2 by 3. If EF is 4 times, then automatically that Fermi temperature also 4 times of the n to the power of 2 by 3. Therefore, Fermi temperature increases factor. How much factor it is increasing? 4 times increasing. Sorry, this formula you have to adjust. This is 2 by 3, not 3 by 2. 2 by 3 you have to take it. 2 by 3. Clear? Like this question. This question so many times they are asking Fermi energy formula. Fermi energy is proportional to number density 2 by 3. Clear? N to the power of 2 by 3. From Fermi gas, this question came. Now we will see the next question. The partition function for a gas of a photon gas. This photon gas is nothing but a Blackbody radiation gas. Blackbody, which one it is, Nana? Blackbody radiation. Blackbody radiation gas is there. Such type of gas we call it as a photon gas. Their photon gas, which one they are giving? ln z value they are giving. ln z is equal to, what they are asking? Pressure of the photon gas they are asking. GATE 2010 they are asking this question. This question in CSIR also so many times it came. What is the formula for pressure? Minus dou F by dou V. Minus dou F by dou V at a constant. Minus dou F by dou V. This is a pressure formula. Minus dou F by dou V. But Helmholtz free energy is equal to minus kT into ln z. ln z they are giving. You have to substitute minus kT into ln z is equal to how much value is there, Nana? 5 square V kb into T whole cube is divided by 45 h cut cube into C cube. Now you have to see here F is equal to, here 1 K into T is there, 1 KB into is there. What we have to write? 5 square V KB into T whole to the power of 4 is divided by 45 h cut cube into C cube. This is the F value. But you know, you want to know the P value, minus also is there now. You know the P value. How we have to calculate the P value? Now you have to do the integration. Is equal to minus dou by dou V of minus 5 square V KB into T whole to the power of 4 is divided by 45 h cut cube C cube. 45 h cut cube C cube. So minus into minus plus with respect to V, rest of the things you have to take the 5 square KB into T whole to the power of 4 is divided by 45 h cut cube C cube is there. So this is the answer, right? Which one we have to take, Nana? C cube is the right answer. Now you have to take here 5 square, which one it is? This is the correct option. 5 square KB into T whole to the power of 4, 45 h cut cube C cube is correct option. Clear? Like this we have to calculate. If you want to do all these things, you know the technical skills, how we have to solve the problem. That is very, very important. Without knowing the solving the problem, we are unable to do. These formulas also you come to know. How we have to implement the formula also you know. When we will get this idea, if you know the teacher and our guide, then only you automatically come to know, sir is doing like this, we also do like that. Now we will see. This is the Ising model one. Now we are a couple of minutes we have to end. Consider a system of 3 spins. 3 spins are there is S1, S2, S3. 3 spins, each of which take value +1 and -1. The energy of the system is given by, they are giving the energy of the system. Once you have to take the energy of the system is equal to -J into S1, S2 plus S2, S3 plus S3, S1 they are giving. When J is a positive constant, the minimum energy and the corresponding number of spin configuration are we have to calculate. For minimum energy, how many corresponding number of configurations are there? That one we have to calculate. For minimum energy, how many number of corresponding configurations are there? Once you have to check it. Suppose first you have to take it as a positive spin. Spin up you have to consider. For spin up, positive spin, because 2 spins are there. One is +1, another one is the -1. All the spins you have to consider as a up you have to consider. Then you substitute E is equal to -J into 1 into 1 plus 1 into 1 plus 1 into 1. How much? 1 plus 1 plus 1. So minus E is equal to -3J you are getting. This is the minimum energy. This energy also minimum energy. Right? Minimum energy only we are getting. This is the Ising model problem. Next, one more probability is there. What is that probability, Nana? -1 is there. This is a down spin. If you have to consider the down spin, what will happen you have to see. If you have to take a down spin, now the spin is down, spin is down, spin is down, means -1, -1, -1 you have to take. There you substitute E is equal to -J into -1 into -1 plus -1 into -1 -1 into -1 is equal to 1. Therefore, here also we are getting -3J. This is also which energy it is? Minimum energy only. -3J is minimum energy only. Minimum energy, right? Minimum energy. Then it will be get the maximum energy. Suppose S1 is up, S2 is down and S3 is up is there. Then what will happen once you have to see? E is equal to -J into S1 is up, S2 is down. That is the -1. S2 is down, S3 is up. That is the -1. Now you have to take here S3, S1. S3, S1 what we have to write? Both are up only. Both are up 1 plus 1. Now you are getting +1 -1 get cancelled. +1 -1 get cancelled. Minus into minus plus. E is equal to J. Positive constant. This is the maximum energy. If it is negative, minimum. If it is positive, maximum. You are getting the maximum. Therefore, how many minimum possibilities are there? Only 2 possibilities. All up values, all down values. So, therefore, how many spin orientations are there? 2 orientations are there. What is that magnitude? Magnitude is equal to -3J. Therefore, -3J and 2. Option C is correct. This is the 5 marks question they are asking. You will get the 5 marks. Some simple logic if you have to apply. December 2012 in CSIR people are asking this question. This is very, very important and easy also. Now the last one you have to see. What is a last question? That is a random walk question. Random walk and Brownian motion I kept in the non-equilibrium processes also I kept in that only. Now you able to see what is that one. A random walker takes a step of unit length in the positive direction. Suppose a random walker is taking a positive direction with probability. How much probability is taking, Nana? For first step 2 by 3 plus 1 into 2 by 3. For first step is taking, that step is plus 1 into 2 by 3. For one step I am taking for positive direction. Next, in the same way, in the negative direction, the random, what is the probability of the negative direction? Minus 1 into 1 by 3. For one step, there is a possibility of 2 by 3. There is a possibility of minus 1 by. For one step, the probability is equal to 2 by 3 minus 1 by 3. This is the total one. So 2 by 3 minus 1 by 3 is equal to 1 for one step. What they are asking? The mean displacement of the walker after n number of steps. For one step 1 by 3 is getting. For n number of steps, for n steps, how much you want to walk? What is the probability? N by 3. What is the probability? N by 3. Option A is correct. Very, very simple. Random walk, and sometimes the Brownian motion equations also you will get from, sometimes the diffusion equation also you may get, sometimes non-equilibrium process questions also you may get in your CSIR examination or GATE examination. These are the 10 parts. From 10 parts also, from each and every part, one question I explain in statistical mechanics. Please concentrate. Like this you have to segregate and you have to take the book, you have to read. Otherwise, you come to my app and you purchase my app, you listen my classes, you will get more idea and you will get the more perfection in that field. CSIR and GATE batch commence from 7/1/2024. Live plus recorded classes will start 6 AM to 8 AM. So Apple is not there now. You have to go to the Play Store and download my app, Quantum Online Academy app. From that app you have to purchase. If you have any doubt, you call me. These are my numbers. My regular number is 990-843-7460. My institute number is 630-326-3368. Right? So very, very interesting batch. Thank you. Thank you for listening my classes. Please share and subscribe my channel. At least 1,000 subscribers will come. Then I will start some live classes. Those live classes, current affairs, science and technology live classes I want to start. But our ultimate goal is CSIR and GATE only. CSIR and GATE only. I want to make you as a experts in the physics field. What are the challenges are facing today? How we have to solve those challenges by using the physics. That is very, very important. To grow the country, growth, science and technology is very, very useful. That science and technology is the backbone of the science and technology is the physics only. Please concentrate and do and enhance your physics knowledge. You get something in the physics and then you sustain in the physics field. Thank you so much.